Hello guys, welcome back to my channel. Today's question is count subarrays with fixed bounds. Now problem statement is we are given an array called nums and two integers that is min k and max k. Our task is simple. We need to count the number of subarrays where the minimum element is exactly min k and the maximum element is exactly max k. Let us go through an example to understand this better. Here example 1 is written. So the numbers are 1, 3, 5, 2, 7. First let us understand what is a subarray. A subarray is a continuous part of an array. Alright. So in 1, 3, 5, 2, 7, 5, the subarray should contain minimum 1 and maximum 5. We can see that this 1, 3, 5 is a subarray that can have minimum 1 and maximum 5. And 1352 is also an array that has minimum 1 and maximum 5. So these both are subarrays. Here they are counted and the answer is 2. So how do we solve this question? The first thing that comes in mind after seeing any question is the brute force approach. And in brute force approach, what do we apply is, for example, if this is a question, what will be the brute force approach to find the summaries of it? Suppose I need this, 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 and this. These all are subarrays of this array. Apart from this is just iteration of the right, and when we will iterate it from left, we will see that this is gone and remove one, and we get another set of subarrays. Just the criteria it must be continuous. This can further be expanded to let us say start from 5, that is okay. This is gone. Sorry. This is gone. This is gone. This is gone. This is gone, right? So likewise we do this up to end till we don't reach here. So what we get is we say that 6, 5, 4 until 3, 2, 1. So the time complexity from this and what is the minimum and maximum element we get here? One is this, where the minimum and maximum we can get is 1 and 5, and the second one is these two are the elements where we can get minimum and maximum as 1, 3 and 5. After that you can see that in next example the minimum is 1, but the maximum is 7 in both the cases, and in the above cases only minimum is present, maximum is not present, and in rest of the cases, that is from uh, here onwards, we can see that one will never happen, means minimum will always be missing, so we cannot have a maximum number. So only the subset that can be considered, hence we return 2 in the output. Now let us see what is the other way to solve this problem. Let us move it aside. From this, can you guess which data structure or algorithm is used to solve this problem? If you have guessed it to be a sliding window protocol, then that's the correct answer. If you have guessed it to be a two pointer, then also it is a correct answer. So let us see that we have 3 pointer that all starts from here, -1. Let us make it red, green, red, yellow, and green, the red is minimum, yellow is the bond, and the green is maximum. So 1 is minimum, we move 1 here. Now next is 3. 3 is neither out of bond, 3 is neither minimum nor maximum, so we can ignore it. Next is 5, which is maximum, and we see that from here we get a set, and hence the count will be increases from 0 to 1. Now what about 2? 2 is neither out of bond, neither minimum nor maximum. So what we say it to be plus 1. Now next we go to 7. 7 is an out of bond, so we will add this here. Now we don't consider anything before this. Now we will start new, that means afresh, and we will list here everything. And now either list here or keep it listed there, but after that we will increase it once we find an element greater than this. So what if we next element is a max element, so we are putting our green here, but after that there is no element, so 2 is the answer here. What if we take a considerably large set of array? Suppose that minimum here is 2 and maximum is 5, and the example is this. Suppose all is there at -1, so we take red, green and yellow. Yellow is an out of bond indicator. Okay, let us take blue. Okay, so first is out of bond itself. Second is minimum. Third is neither out of bond nor minimum nor maximum, so we can ignore it. 5 is maximum. We put down here, as we get a minimum and a maximum, we say that we have found at least one element, means at least one sub array with fixed bounds. Now what we will do, we will look at 7. 7 is an out of bond, so we will increase it to here. Now next is 3. No, not out of bond, not minimum, not maximum. 2. No out of bond, nor minimum, nor maximum. 4. No, 2. 2 was the minimum. So we make our minimum here. 4. Neither minimum, nor out of bond, nor maximum. 5. 5 is the maximum. So we will put our 5 max pointer here. Now we can see that after this out of bond, we are successfully able to find an element which we can say that we have formed an array here. The first array was 2, 3 and 5 here. The second is, we can say that we have found here 2, 4 and 5. But is that what we have found? After out of bond, we have found two subarrays here. One is 3, 2, 4, 5 and another is 2, 2, 4, 5. So how we will calculate it? In that case, what we will be doing, we will be taking the minimum of these two and subtract the index of out of bond from it. For example, here the index of 7 is 4 and the index of 2 is 6. So we will subtract minus 4, that is 2. So we will add here 2. Right. Now next we see that it is 3. What is 3? 3 is neither out of bond nor min nor max. But what if 3 is added to 2, 4 and 5? So once the 3 is added in 2, 4 and 5, it becomes 2, 4, 5 and 3. But is 3 just added to 2, 4 and 5? No, it is also added to 3, 2, 4 and 5. So what is the case here is that once we increase 2 or the previous number, we will be just incrementing that only. After each element, if till now we have gone 5, so if if there would be a case where I have seen 5 elements after out of bond, then after we get a proper subset, if an element is increased, we will increase count by plus 5. But if you still have doubt, you can ask below in the comment section. Now next is 2. What is 2? 2 is min. So we move our pointer here. Once we move our pointer here, we see that we found another set 5, 3 and 2. But will we just add 5, 3 and 2 as plus 1? Or we will take minimum of those, that is 5, and subtract 7 and subtract the index of 7, that is 4 from it. So what is the index of 5? 5, 6, 7, 8. The index of 5 is 8 and the index of 7 is 4. So what we will do, we will add here 8 minus 4, that is 4, which implies that there are subset here. Now let us see what are those 9 subsets. 5 are already mentioned here. Let me mention it from 6. Let me change the color to green, and now let us see that this 5, 3, 2 is a subset, right? 4, 5, 3, 2 is a subset. Next 2, 4, 5, 3, 2 is a subset, and next 3, 2, 4, 5, 3, 2 is a subset. So we see that 4, 5, 6, 7, 8 and 9. We have mentioned here all the subsets, that is 9. So the count will be 9. So first we have used recursion method. For that the time complexity was order of n square, and now after using sliding window protocol, time limit has reduced to order of n. Right? And we got the correct answer. Now let us implement it in the code. What we will first say that we have to return a result, which is of course initially 0 because we need to return an element in int, and return dress, right? This is our base case. Now what do we say? We set 3 pointers: min pointer, max pointer and left bound. Now what we do is we run for loop. Now what we check if out of bound if nums is less than min k, or nums is greater than min k. In both the cases, left bound is equal to I. Otherwise, what we see that if nums is equal to min k, I think that I need to provide some space here for better readability. So if nums is equal to min k, the min pointer will be equal to I, or if nums is equal to max k, the max pointer would be I. Now, what we say that once we find this, what we say, we add, what we add? We add maximum of 0, comma, okay, minimum of, first we will find minimum of left and right pointer, that is minimum of min pointer, comma max pointer, and then we will subtract left bound out of it, and then we will see that whatever is the maximum, if it is a negative number, that is -1, don't add it. Maximum we will always choose 0, that nothing is added, or add the positive subarrays. So let us try to run it, and we did get a wrong subtest case. So let us see where we are going wrong. The output is 0. The output is 0. The output is 0. Where I have made the mistake. Oh, run. Okay, let us submit it, and great. Yeah, it has passed all the test cases. So that's it for today, guys. So using sliding window approach, we reduce the complexity to order of n, which is super efficient. If you found this explanation helpful, don't forget to like the video, subscribe to the channel, and leave a comment if you have any questions. Thanks for watching, and see you in the next one.